You and I use the internet every single day, right? But have you ever stopped to wonder what is actually happening behind the screen? Well, we're going to pull back the curtain on all that magic. In this explainer, we'll follow just one single click on its wild journey across the entire globe and back, all in literally the blink of an eye.
Okay, so let's do this. We're going to follow one tiny piece of data, what we call a packet, on its incredible trip from your fingertips out into the world and all the way back again. It's a journey that's happening billions of times a second, and by the end of this, you'll know exactly how it all works.
It all kicks off with something super simple, something you do without even thinking, like searching computer network on Google. Now that click, it doesn't just stay put on your computer. Nope. It instantly fires off a request, kind of like a tiny digital message in a bottle, tossed out into the vast, vast ocean of the internet. Now, to send that message, your device obviously needs an address, just like sending a letter. But here's the real kicker. It doesn't just need one address. To navigate the ridiculously complex highways of the internet, your computer actually needs two completely different kinds of addresses just to find its way. So the very first part of this trip, it's super local. It all starts right there inside your home or your office, on what we call your local area network, or LAN for short. You can just think of it as the private, digital neighborhood where all your connected gadgets live together.
Let's use an analogy. Imagine your LAN is one big office building. Your laptop's in one office, your phone is in another, maybe your smart TV is down in the conference room. And the thing that connects all of these rooms is a little device called a switch. Its whole job is to be the internal mail carrier, making sure that messages get delivered to the right room inside the building.
So how does the switch know which room is which? Well, every single network-ready device on the planet has something called a Media Access Control Address, or a MAC address. This is a permanent, unique serial number that's literally burned into the hardware by the manufacturer. It's the unchangeable room number for your device within that office building.
And here's what's so slick about the switch. It's smart. It doesn't just stand in the hallway and shout every message for all to hear. Nope. It listens, and it builds a little map of which MAC address lives in which port. So when your laptop wants to send a file to your printer, the switch knows exactly where that printer is and delivers the data directly, privately, no fuss.
But here we hit a snag. A MAC address is fantastic for that local delivery, but for sending your search requests to Google's servers, which might be thousands of miles away, yeah, it's completely useless. That local room number means nothing out on the global stage. For that, we need a totally different kind of address and a different kind of mailroom.
And this brings us to the gateway to the entire world, your router. If the switch is the local mail carrier running around inside the building, the router is the main mailroom for the entire building. Its job isn't to deliver stuff internally. Its job is to send your mail out to the rest of the world.
And to send mail globally, you need a full street address, right? And that's exactly what an IP, or Internet Protocol address, is. Now, unlike that permanent MAC address, your IP address is a temporary, logical address that your router assigns to your device. It's what lets any other computer anywhere on Earth find you.
Okay, so let's just put this all together real quick. You've got that permanent MAC address, your room number for all the local chats handled by the switch. And then you get a temporary IP address, your global street address, for worldwide communication that's handled by the router. Your computer is brilliant. It just seamlessly uses both to talk to the device next to it and a server across the ocean.
So your computer is pretty smart. It takes one look at the destination IP address for your Google search, and it immediately realizes, hey, that address isn't in my local building. So it doesn't bother the switch. Instead, it packages everything up and sends it straight to its default gateway, which is just the fancy name for your router, to get it mailed out to the wider internet. Okay, so we've got the addresses figured out, but how is the data itself actually prepped for this big journey? I mean, you can't just send it as a chaotic mess of ones and zeros. The internet relies on a really strict set of rules, or protocols, that basically act like a shared language. It ensures every device packs and unpacks information in the exact same way.
This whole packing process has a name: encapsulation. Honestly, the best way to think about it is like putting a letter inside a series of envelopes. Your data, your search query, starts at the application layer. Then, the transport layer wraps it in an envelope. The internet layer adds another envelope with the IP addresses. And finally, the network access layer adds the very last envelope with the local MAC addresses, getting it all ready for that first little jump to your router.
Now, one of the most critical pieces of that packaging is the port number. Think of it like this. On an envelope, you might write "Attention Sales Department." Well, port 443 does the same thing. It specifically tells the server at Google, hey, this message is for your secure web service, the one that handles all the encrypted HTTPS traffic. It's how your request gets to the right application on that massive server. Your computer also gets to choose its delivery service. For something like a web page where you need every single piece to arrive perfectly and in order, it uses TCP. That's like sending a package with tracking and delivery confirmation. It's a bit slower, but it's guaranteed. But for things like a quick address lookup or streaming a video where speed is everything, it uses the much faster UDP. That's more like a fire and forget postcard. Fast, but no guarantees. All right, we've collected all the pieces of the puzzle. We've got the two different addresses, the switch, the router, and the protocols. So now let's put it all together and trace our one little data packet on its full, mind-blowing round trip from your click to Google and all the way back.
So in less time than it takes to blink, here's what happens. First, your PC sends the data addressed to your router's MAC address. Your router gets it, rips off that local address, and sends the packet out to the big internet, aimed at Google's IP address. Then, that packet plays a game of hopscotch across dozens of routers all over the globe, with each one pushing it closer to its final destination. And finally, when it arrives, Google's server reads your request and sends the answer all the way back, doing that entire process in reverse to get back to your screen. Incredible.
So you see, when you boil it all down, this unbelievably complex system that we call the internet really works because of just a few really elegant ideas. It's a network of networks, all tied together by routers. And all of our data is guided by those two key addresses, the local MAC for the little hops and the global IP for the final destination. It all just works.
And that leaves us with a fascinating last thought. The system we just walked through, the one based on a version of IP addressing from the 1980s called IPv4, well, it's running out of room. We are literally running out of addresses. With billions of new devices coming online, the very foundations of the internet are having to be rebuilt to handle the future. But that's a story for another explainer.